Okay. I think last time I gave you the practice. I give you around 4 questions. So the first did. Wait a moment. Okay. I think we can just review the practice. So the question is we need to check the area between the cosine x and 2 minus cosine x. So I believe you should be able to draw this. Okay. And then the concept for area between the curves is always the curve on the top minus the curve on the bottom. Okay. Always like that. And then do the calculations, and you will see that the result is 4 pi. Okay. The other questions is the same questions actually, but different curve. Now you have x equal y with the power of 4, and then y is equal square root of 2 minus x, and line y equals 0. So you have three curve and line. Now the first thing you need to do is you need to draw, okay? To draw the curve of x equal y with the power of 4, you should be able to draw that. Y equals square root of 2 minus x, you should be able to draw that. Okay, let me. Okay, so you have. So the blue color is the x equal to the 4. So we can actually evaluate the area with two approaches. Okay? The first approach is we have the blue line here, the red line here. We have two area, A1, A2. We need to look the intersection, find 0 to this intersection, and then find the other one, and plus the 2. That's the first one. The other one is, I think, easier. You can use dy. You can use dy, and then this become the top curve, and this become the bottom. Okay? So if you are looking from the perspective, this become the curve on the top. The red one become the curve on the top, right? And to evaluate the if you're looking for dy, then you need to change all the information, become x equal y. Okay. For example, we have the x equal y to the 4. That's already y to the 4. And this, you need to switch x and y, right? So it become x equal 2 minus y. So first, you can have two approach, okay? Using dx or dy. If you are using dx, you will have a little bit problem with the second integration. Square root of 2 minus x, right? How you solve this? Any idea? How to solve this? Square root of 2 minus x. Substitution will not work. Square root of 2 minus x. Any idea? Actually, we will learn this this type of question in chapter 7, but I will briefly tell you what this is about. Any idea? No? If I have sine, we know this is 1, right? We can conclude that this become this, and this become this, right? If our x here, okay, if we substitute with, for example, sine or cos, and then the dx, for example, if we substitute to let's say let's say sine theta or sine squared, or maybe 2 sine squared. Yeah, let's say this become our substitutions. So this will be what? 4 sine theta cos theta. Okay. Now, if you want to substitute this inside this, then this become 2 minus 2 sine, or let's say so this become 2 cosine squared theta, right? And dx become 4 sine cos theta d theta, and this becomes square root of 2 cosine. Let's combine this 2 sine theta and 4 and integrations and d theta. And you need to also figure this theta 1 and theta 2 from this x1 and x2. And quite a long process, but eventually you can solve this. Okay, you can solve this integration. This is called the trigonometry substitutions, in which you can substitute the variables with trigonometry with other variables, let's say the theta. Some can be used for a sine or cosine, and some you can use tangent, because tangent can be related to secant, right? So you can look up this method, but I will going deep more details later. Okay, this is actually chapter 7, but if you want to try using trial and error, you can try with this cosine or sine and try to solve the equations, solve this one. But anyway, the second one, this one, is more direct, and it's much more easy than the using the dx. Okay, so you can go through dy. It's much more easy. You can get the results directly. Okay, so choose wisely when you are looking at the graph of your integration, which method to use to evaluate the area, okay, using dx or using dy. Mhm. If you right? Okay. I think yeah, it's correct. It's correct. Yeah, it's correct. Yeah. Anyway, you can actually directly integrate this. If you have this, I think you can directly integrate this, right? But anyway, if you find this and maybe it has a more complex structure, like having a fraction, maybe at the bottom like this, and you have some functions here, and you can substitute easily. You can do the trig sub Okay. Yeah, this is the second one, the part 2, and that is when we are using dy. And the other, this is the third one. Y is equal 1 over 4 x squared, y equal to x squared, x plus y equal 3, and the x should be positive, greater equal 0. This is the graph. Okay. So y equal to x squared, y equals 1 over 4 x squared, and x plus y equal 3. Um, you can look by dx up until here. This is the area 1 up until the intersection of blue and green. And after that, the area 2. Okay. Or you can, I think you can also use dy and make this area as A1 and A2, become 2 area. Okay. So you can use A1, A2 if you are using dx, or if you are using dy, you can use here, okay, A1, A2. Okay. If you're still confused on how to get the intersections, please let me know. Okay, if you're still confused on how you make the A1, A2, and how to make the endpoint of the integration. Okay, because that's the whole point in this chapter. Okay, the integration parts, how to integrate. Usually, the function is not really complicated. This function, okay? It's not too complicated. The difficult one is to set up our integration. That's the difficult one. How to choose which area you want to evaluate, which endpoint you want to put in your integrations. That's the most difficult part in this chapter. The other part, like how to integrate, it it is simple functions, right? It's not too difficult. Okay. Anyway, to find this 2 point, we need to find the intersections, right? So we need to equal the line and the curve. So we need to find the intersection. So finding the intersection. So we get the x equal 1 because we don't need the negative one. It's outside of the range. So x equal 1. And then the other intersection is x equal 2. So 1 and 2. So A1 will be 2x squared minus 1 over 4 from 0 to 1. And A2 is 3 minus x, the line, minus 1 over 4x squared from 1 to 2. And I believe this 2 integration is not too difficult to solve. Right? The difficult part in all uh, uh, like these questions is to find how to find these intersections and how to set up the integral. To integrate, to calculate, it should be easy. It should be easy. And then you get okay. Now The next question is a little bit for what values of m do the line y equal mx and the curve y equal x over x squared plus 1, they have region in between of them. You need to find the area of the region. Okay. To draw the curve, so this question is a little bit more complex. So you need to be able to see what kind of curve you will have. So this x equal over x squared plus 1. What kind of curve? So the first thing you can do is you can check with the application of derivative, chapter 4, calculus. So check the first derivative, check the second derivative, check the minimum value, at least finding critical points if you want to look up the graph. Unless you want to trial and error, finding 0, 1, 2, plug in the points, but maybe it takes a long time. But I think you can derive, not too difficult, derive this. Okay, you get some results here. The first derivative, and you get the critical point is -1 and 1. The critical point. So you check. This is the minimum value. -1 is minimum value, and 1 is the maximum value. You may check also the result. -1 plug into the original equation. What is the value? I think it's around half and -half. So if you translate this, or if you want to check the second derivative, if you want, I think up until here, the first derivative, you already at least having from this part. I think that's enough. But if you want to look more to check what is actually going on, you can check the second derivative, and you will see that there are 3 inflection points here: the negative square root of 3, 0, and square root of 3. If you want to check, but I believe up until the y prime, you already get the idea. From -1 until 1, the graph will like that. So this is your line equation, y equal mx. And you need to conclude here from the graph that the y equal mx will cut through the curve, and it will have this whole area and this whole area. Okay, this is pretty much symmetrical. So when you're doing the calculations, you can just use the one area and then multiply by 2. Because from the graph, from what we have done in derivative, we know that this is symmetrical. Also, you can also check actually the odd and even functions. Why it's going down and it's going up? It's the odd functions, right? If the curve is even functions, it will going here and maybe here, or maybe going there here. But because it's odd functions, it's going down and then going up. And then we find first the intersections. Find the intersections. We get these expressions. We will look up this expression later. And if you want to solve the second derivative, if you want, finding the inflection point is 0 and x squared is 3. So square root of 3 and negative square root of 3. So you get the inflection point. Okay, so these expressions telling you that x is 0, or you will have this whole quadratic functions is 0. So you have two possibility, right? So to solve this one, let's rearrange our formula. So x squared become 1 minus m over m. So we get the results plus minus square root of 1 over m minus 1. Okay, now we also have another possibility. If m is 1, then the whole x will be 0, right? If 1 over m minus 1 is the whole thing inside is positive, then you will have to you have the interval from 0 to 1. So your m, if you want the whole number inside the square root, if you want this to be positive, then your m should be a fraction. Do you get it? So m should be from 0 to 1. Any number in between these two. Okay. So it will be two solutions, but let's see the other considerations. We can also consider the tangent. Okay. We can consider the tangent. Okay. The tangent of origin, meaning the tangent at x equals 0. We get the y prime, the slope. This is the expression. If we put 0, x is equal 0, then our y prime or our tangent, our slope is 1, right? So that's why, because it's 1, then the slope or the m is maximum is 1. And m is positive, right? X is positive, right? So m should be in between 0 and 1. You can also take this as your considerations. The maximum m should be 1. So the m that you derive from here, it should be below 1 and greater than 0. So in between 0 and 1. Okay? So you will have, because it's plus minus, the intersection will be negative square root 1 over m minus 1, and then positive square root of 1 over m minus 1. Okay? So you set up integrations from negative, so from this intersection until here. But like what I said before, this is symmetrical. You can do from 0 to this square, the positive 1. Okay? No need to include all. Okay? Because it's quite messy, right? If you include all and then you don't really have much time to solve this. Then we can make this become multiply by 2 because it's symmetry from 0 to the positive 1, and then the curve minus the line, the mx. And we can compute this. We can evaluate the left one. We can just use substitutions. And then you get the ln. And then put in the endpoint 1 over m minus 1 square root. Going here, become 1 over m minus m. Put in here, become 0. So the results will be, the area will be m minus ln m minus 1. Okay. Okay, this question is, if the question in previous page is maybe level 1 or 2, this may be level 5. Yeah, it's more complicated. Okay. Do you have questions? I will share the all the notes for the practice to you later. Okay. Okay. We still have two more questions. Number 3. Well, I think I can use the other one. Let's wait a moment. Okay. Now, yeah, this is the question number 3. So find number b such that line y equal b divides the region. Uh, the curve is y equal x squared and y equals 4. So there will be a line y equal b and dividing the area into equal area. Wait a minute. Okay. Okay, so first thing, draw the graph. Okay, first thing, draw the graph. Draw the all the informations inside the graph. Um, the curve y equal x squared, y equal 4, and y equal b. So based on the questions, the area in between from 0 to b and b to 4 should be the same area. So we need to set up the integration first. Okay. Set up the integrations and integrate and simplify and put in the b inside. And I think this is not too complicated. Okay, not too complicated. And you get the b is cubic root of 16. So this is after you get this expression and then solve it. So I think to set up the integration is the most important task in whole chapters. In area, also in the next in the volume, that's also important. Okay. The number 4. This is so you have a 2 parabola. Okay, so uh, c squared minus x squared and x squared minus c squared. So you have two parabola. You have the area inside. Okay, and then the area should be 576. The area, and it's asking about the c. So there is c inside the equation. So we know that from the quadratic expressions, c will be the roots, right? Will be here. Okay. So we can just set up the equations, set up the area, set up the area from negative c until c, and this is the whole formula. But this is if you want to evaluate from negative c until c. But if you see the area here, it's pretty much the symmetry, right? The x squared minus c squared and c squared minus x squared is the same exact curve but mirror each other, right? So we can divide this into 4, and we can just only evaluate this and multiply by 4 to simplify our calculations. But if you want to calculate all, including the negative c, that's still fine. That's still fine. You will get the same results. But to avoid the miscalculations, to be honest, uh, I also doing the same mistake. If I want to calculate like the positive and negative, and then at the end results, I'm doing some mistakes, and it happens a lot to me, honestly. So when I'm dealing with this kind of situations, I need to simplify and make the symmetry. That's much more easier. And this is the integration setup. So we just need to calculate this integrations, put in c, and we get 8 over 3 c cubed, the area. We need to find the c, right? So we need to equaling the equaling to the 576, and then find the c. So we got the c is 6. Okay. 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 Do you have any questions? Any questions? So in the integration, whenever you see the symmetry, what I'm suggesting is you can simplify your number, okay, and avoid the negative positive mistake. Sometimes because in integrations, let's say you have negative 3 until maybe 3. Whatever happened inside, you need to evaluate the 3 minus negative 3, right? And when you evaluate this, because you have this negative, you will have, if you don't careful enough, you will do some mistake here and you get the wrong answer. Okay, so that's why I prefer if you find any symmetry and you can just evaluate from 0 to 3, it's much more safe, much more safe. My suggestion. Okay, now I want to move forward to volume. Okay, to go to volume, the second section in chapter 6. And because we will have next Friday quiz. Okay. Next Friday. Yeah, next week. Chapter 5. Okay. So I will doing a little bit review next Monday for chapter 5. Okay. So I'm doing chapter 6, and then maybe a little bit chapter 6 on Monday, and then chapter 5 to review what we have done in chapter 5 to prepare your quiz. Okay. So I think we can move forward to volume. So this is still chapter 6. Okay. This is still chapter 6. Okay, let's say you have the this the curve, and let's say this is y f x. Okay. Yes. Oh yeah. Oh yeah, 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 yeah. Yeah, 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 yeah. Yeah, I think I can make adjustment. Okay, I just remember that you have field trip, right? Yeah, 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 yeah. So maybe I will adjust the schedule. Okay. So maybe not next Friday, but maybe the Monday. Okay. After the Friday. Okay. So Monday. Next. Okay. But does anyone tell you how the schedule and how to get to the industry? Bus or bus, right? Okay. 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 So I will make an adjustment and just wait for my announcement. Okay. At least it will be after your field trip, the quiz. Okay. Okay. Now the curve. If you want to evaluate the area, as I mentioned before, if you are evaluating with the dx, then the area will be all the rectangle from here. You are plus all the rectangle. You sum up the rectangle, and you get the area under the curve. If you evaluate the functions with this line as boundary. Okay. However, if you uh, rotate, okay, if you rotate this, okay, so if you rotate the curve, what will happen? Okay, maybe it will become like this shape, like a rugby ball, right? But take a look the rectangle inside. Take a look this one. Okay, if you have like a rectangle, you rotate the rectangle, okay, and you will have. Let me draw here. You will have something like a disk, right? Disk, or you can observe that as like a tube. Okay, so if this has the, let's say the radius r, and this is the height. The volume is area multiplied by height, right? So area is pi r squared and h. Okay. And in our case, the volume will be this area multiplied by the height, dx, right? So the radius is the function, right? It will change along the function. So that's become our radius. So pi r squared, the r is the functions. So let me mark this as r is the function of x. So the volume is integrations. If this is from A to B, this is integration from A, B, and then pi fx squared dx. Okay. This is the basic concept to understand the volume. Okay. We call the volume also in terms of solid revolution. Has any one of you learning any software, drawing software? Sketchup. Is there any conversion between 2D to 3D in SketchUp? Yeah, there is, right? Yeah. So uh, to make the conversion from 2 dimension to 3 dimensions, I think in most software, when you later learn the software, so if you have the technical drawing, for example, you are making a circle, and then it has a certain radius. Maybe it's like having certain height here, and to convert 2 dimension to 3D is actually it's similar way when we are rotating our integral to find the volume. So for example, if I from here I want to rotate this into this line, okay? So the image, the mirror image will be here, right? And imagine this going all the way from here to here. Got it? It will be like if we are rotating here and we are looking from this side, it will be, we will have this becomes solid here. And if this is hollow, if this is hollow, then this is hollow. So where is this 2D projection from here? The 2D projection is here. So we are going here, rotate, and here is rotation. So this is this line is here. Got it? So most of the 3D software, when you translate the 2D dimensions to 3D, there's I think a lot of software. But I think when I learned one software called the Autodesk Inventor, I'm drawing the technical drawing. I draw that, and then I just rotate the 2D projections with the the tools called the extrude the drawing and make the 3D object from the rotations. And that is exactly what we did with our integrations. So we convert the 2D projections to 3D. So sometimes you need to a little bit use your imagination to imagine what the shape looks like. Okay, but because if you are imagine from whole curve, maybe the curve will be a little bit weird or maybe like not possible to be drawn. You just imagine the rectangle, much easier. Imagine the rectangle here. So the disk, this disk. If you imagine the whole curve, maybe you will get like weird shape. Okay, so better just to look up the rectangle. Okay. Okay. Let me write a formal definition, official definition. It's a little bit having terms, and let me give you the image. Okay. So let S, okay, this S volume. So let S solid between A, B. If the cross section of S in the plane BX through through X and perpendicular to X-axis is A. Okay, let's say we have the function of the area. Okay, where A is continuous function. So we need to have continuous functions. Otherwise, we will not have the integrations, right? So then we go back to our definitions for the integrations using limit and the sum. And we can write this as AB to AX dx. So all the words, the definitions is what I'm trying to tell you before. Let me give you another. So this is the example. And this is also the example. Okay, so if you want to define the solid volume, we need to define the solid to be a random functions. Okay, I give you the disk because that's the most general case in our calculations. So this is the area This is the delta x. So it's just approximation from this height multiply with the area and become the volume. And we need to plus all the volume, small volume here, become the big volume. And we can, using this setup of integration from A, B, the functions, area functions, multiplied by dx. Okay, I think because we only have around 30 minutes, I will give you the common method. And maybe if you still have time, I will give you more example. Okay. So first, if you have so let's say we are rotating through x-axis. This is x, this is y. So if we are rotating, we will have this kind of this. This is ax, and this is dx. The volume will be if we have a and b. So if we are observing a to b, then the volume will be pi. Let me write the functions. The function is y equal fx. Let me write the y squared first. And then it's equal pi fx squared dx. This is the first case. The first case is given y equal fx. The second case, given the x equal g of y. So now we are rotating through y-axis. Let's say this is our graph. And this is the A, let's say C, and then this is D. And now our rotation or our disk is this one. And now it's not dx, but dy. And this will be ay. We can write the volume square the integration from C to D. C to D and pi. Let me write x squared dy. Okay. Okay. We call this method, this two way here, we call this is the disk okay. So the first one if you have the function of x, the second one if you have the function of y. Okay. Okay. And in some cases, okay, the volume you can choose dx or dy depends on your decision. But mostly, if you rotate through x, mostly it's dx, if the function is simple enough. And when you rotate to y, then you use the dy. Most of the case, if you have the simple function. I think I can give you several examples. Okay, any questions so far? Okay, let's try some examples. So find volume of solid Okay, this is just a simple question. Okay, should be able to draw the square root of x. Okay, let's say 0 and maybe 1 is here. Yeah, maybe this is the y equals square root of x. Now you need to rotate to the x-axis. So you will have this rotation. Okay. So this will be the radius. You can say you can write down the ax by square root of x squared, and you can set up the volume from 0 to 1 by x dx. And you can directly write the half x squared, and it will be pi over 2. Okay, so this is basically really simple functions, uh, easy calculations. Okay, but remember, the center of rotation can be anywhere. Okay, but most of the case in the whole calculus 1, you will only see, if not x, y, then the line. Maybe y equal 2, y equal 4. That will be the center of rotation. I think that will be the most of the cases. Okay, I think this is too easy, right? Let me give you a little bit more complex one. So find, I think the question will be the same. I will just write the curve. Okay. So the curve is x okay. So we have all the curves, x equal y squared, x equal 2y, x equals 0, x equals 4, rotate about x-axis. Find the volume of the region in between the curves. Try to draw and imagine the curves and how the volumes will look like. Did you understand this one? Yeah. The previous one, do you still understand this? But do you understand all that? No? Wait. Okay. Before we move on, is there any question from here? Any question here? Any questions? This is the easiest question. Okay. Any question here? No? You got it? You got it or not? Okay. The idea is just find the area here. Okay. Okay. Now move on to this question. So x equal y squared, x equal 2y. So it's the same, actually the same curve, y equals square x, right? From before. X equal 2y is just a line, right? We have x0, x4. It's just the boundary, right? The boundary for integrations, probably. Okay, my question is just try to draw first. If you feel you cannot draw this, please let me know, okay? Please let me know. Because most of the problem you need to solve by at least drawing first and then solve the integration. Coba gimana? Gimana cara tahu ya? Ya kalau kamu nggak pakai tanda dia berapa ya nggak akan tahu dia ada di mana. Karena ini masukin angka-angkanya 1 atau 2, nggak perlu bikin bagus-bagus. Nah, gimana? Kalau diputar gimana? Udah. Bagus kameranya. Kamu anggap aja ini ada penuh gini. Kalau diputar kan ada disknya gini kan. Berarti kalau ini ada kayak ada begini, berarti disknya gimana? Nah, gini aja. Kamu bayangin kalau nggak ada garis ya. Kalau ini diputar begini kan dia ada disknya kan. Kalau dia ada garis, gimana? Ada yang motong kan? Berarti gimana? Iya, benar. Imajinasi. Iya, 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 iya. Iya. Kalau kamu cuma ngambil di sini, anggapnya di sini ada bloknya di sini. Kalau diputar kan, dia tetap jadi disk tapi bolong tengahnya kan. Iya. Iya. Berarti, berarti ngitungnya gimana? Tetap pakai disk kok. Tetap pakai disk. Ngitungnya tetap pakai disk. Kan ada bagian yang kosong tuh. Iya, minus. Area 1 kurang area 2.